Alright, so before we get into investigating chapter 4, we're going to start off with some terminology that you need to be familiar with in chapter 4, Foundations of Math 11. So what is an oblique triangle? Well, an oblique triangle is a triangle that does not have a 90-degree angle. So if we were to draw a diagram for this, let me just zoom in a little bit here. Okay, we would just draw a triangle and there would be no 90-degree angle within. So there's our triangle. This could be maybe 40. Oops. The one over here could be 60 or 65. And that would make this angle up here 85 degrees. So there we go, there's an oblique triangle. Now what's an obtuse angle? Hopefully you're familiar with this from the grade 10 math. So an obtuse angle is an angle greater than 90 degrees. So if we were to just draw an example, say this angle right there was 130 degrees, that would be an obtuse angle. What about an obtuse triangle? What's an obtuse triangle? Well, it simply is a triangle that contains an obtuse angle. So if we're to zoom in here to draw a diagram, if we had, that would be our obtuse angle right there, and then we'd make a triangle. That angle maybe is 160, and then we would have our obtuse triangle, which contains an obtuse angle greater than 90 degrees. And lastly, what are supplementary angles? Well, we discussed this in the previous section. Supplementary angles are two angles that add to 180. So we know that a straight line is 180 degrees, and if we cut it with a transversal, this side right here, if it's 120, then we know that this side over here has to be 60 degrees. And these two angles here are supplementary. Okay, so let's take a look at this investigation in terms of the sine ratio. So over here on the left of this table, we have theta, which is a value of different angles. So this is an angle of 2 degrees, 10 degrees, 20 degrees, etc. Over here we have the sine theta. So what I've done is I've punched in sine of 2, which equals this. And over here, I've taken this angle and subtracted it from 180, so I got 178. And then I'm going to punch in sine 178 and see what I get. So first I want you guys to pause the video and punch in sine of 2 degrees and see if you get this ratio. Next, what we're going to do is punch in sine of 178, which is 180 minus 2 degrees. So if I punch in sine of 178, I get that the ratio is 0.0349, which is the same number that I got when I punched in sine of 2. Coincidence? I don't know, let's just see. So sine of 10 degrees gives us 0.1736. If we do sine of 180 minus 10 degrees, so sine of 170, what does that give us? Well, as you can see, it gives us the same ratio again. 0.1736, 0.1736. So let's try here, we're going to try and do sine of 20, which gives us 0.3420. And now if we do sine of 160, which is 180 degrees, take away 20, what do we get? Again, you get the same ratio. Do you notice a pattern starting to form here? So we can say that sine, based on the investigation above, sine 2 is equal to sine 178. Sine 10 is equal to sine 170. Sine 15 should be equal to sine 165. Sine 45 should be equal to sine 135. So we get a relationship that forms which tells us that sine of any angle is equal to the sine of 180 take away that angle. So there's a relationship that's been formed. So let's explore the cosine ratio now. Alright, so again, same table. This is theta, the angle. This is cos of theta, and this is 180 minus theta, and we're going to do cos of that. So cos of 2 degrees is 0.994. 180 minus 2 degrees is 178. What is cos of 178? Well, we see that it's the same except for the fact that it's a negative ratio. So the cos of 180 minus theta gives us the same ratio but negative. Let's keep exploring to see if it keeps giving us the same answer, the same pattern. So cos of 10 is 0.9848. What's cos of 170? Well, cos of 170 again is 0.9848 but negative 0.9848. So again we get a negative ratio. Cos 30 is 0.8660. So cos of 150 should give us, and it does, negative 0.8660. So what is the relationship between the second column and the last column, cos theta and cos 180 minus theta? Well, the relationship is that they are opposite. One is positive and one is negative. So if we were to describe a relationship, cos of 2 is equal to negative cos 178. Cos of 10 is equal to negative cos 170. Cos of 45 is equal to negative cos 135. And so on and so forth. Alright, let's investigate the tan ratio now. So tan of 2 degrees is 0.0349. 180 minus theta, so 180 minus theta is going to give us 178. And tan 178 gives us negative 0.0349. So similar to what the cos ratio did. It's the same number but opposite and negative. Let's keep exploring. What does tan of 10 give us? Okay, it gives us 0.1763. 180 minus theta is 70. So if a pattern is starting to form, tan of 170 should give us negative 0.1763. So let's try that out. I want you to try it on your calculator as well. And look at that, it does. So what is the relationship between the second column and the last column? Well, again, they are the same, but one is positive and one is negative. So we can say that tan of 2 is equal to negative tan 178. Tan of 10 is equal to negative tan 170. Tan of 146 is equal to negative tan 34. So, in summary, for any angle, the sine of theta is equal to the sine of 180 minus theta. The cos of theta is equal to the negative cos of 180 minus theta, and tan theta is equal to the negative tan of 180 minus theta. Okay?